So I have a little car here. There is kind of a nice little car. Oh, I also got the wheels turning too, so I thought I'd show how it did. And with the brakes. So let's take a look at what we did. Let's just get rid of everything. So the first thing you need is a rigid body, and I'll show you why. Well, I mean, obviously you're gonna know why, but yeah, turn that down. Is the first thing we're gonna want is a place for our wheel colliders, and I'm gonna put these in. I want to name these right, like front, right. And let's just duplicate that and go front, left, duplicate those and go rear right, and rear left. Now, if I stick a wheel collider on here, you don't see nothing. And that's where having the rigid body is super important. Now I can see my wheel collider. So the wheel collider, if this is front right, we're going to want to put this, I'm going to put it right towards just the edge of the wheel. I just find preference there. I find things to be the most stable, if that's how you kind of set them up. This little point here is actually the point where we're going to be adding force to the ground. The little round part. I'm not too worried about the sizing per se. Doesn't got to be pinpoint accurate. But if that's front right, I'm going to actually parent this one and just zero it off. That'll just be easier to do. Why did that not zero off? Oh, I didn't zero off that part. And then, like we said, with this one, I could literally take this wheel collider, because we've already adjusted the size. Might as well just copy it, and the front left can go over here on this side towards the edge of that wheel. All right, so the rear. Might as well grab them both. And let's add a wheel collider to the rear. Grab them both, so moving them both. The size is probably okay. The actual center of the wheel is technically right here. The rest of that just actually shock. But we can adjust that after. Alright, let's make sure that's towards the edge of the wheel, and then the left one can go over on the left side, only of course it needs a wheel collider. Alright, so there we have 4 wheel colliders. Now if I hit play, it's just going to fly off the frickin' map. And there's reasons for that. You can see like it's already gone, like boo. Because when you're dealing with cars, like you need to use a fair bit of mass. And you can get away with like 700, 800 mass, but then you tend to run into other issues down the road too. So it's kind of better just to go with like a 1500, 2000, somewhere in there. You see now the car is sitting pretty good, just like that. Okay. So what we want is if we want to set up a wheel turning. So the first thing you're going to want to do is go to the ecosystem and look up wheels. There's a pile of actions for wheel colliders, right? Whole bunch of them. So get those because they'll make your life a lot better. So we're going to make a template here. So we need a wheel collider, and we need a wheel mesh, and we need both these to be inputs. Then we also want a angle, and that can be an input. So then all we're going to do, I'm actually going to bring this over and do a next frame event just to make sure. It's kind of a habit I do. And we have set angle, or no, set wheel steer angle, sorry. So we're going to set the angle to our collider to angle every frame. We also want to set a rotation of our wheel mesh on its Y to angle every frame, and I'm going to use self space, and that's it. So if I save template, wheel control, we'll call it. Now if I add now a FSM, and we have get axes, if we're using a new input, just well, I guess you can use a get axes in, well, not this get axes, but you can use a get axes of the new input too. And we have a run FSM, wheel control, and we have, say, the front left collider, and then we need the front left mesh, and we have the angle, which we don't want to just use the axes because it's only one. So let's float multiply. Actually, I guess we don't need to do that. We have a multiplier right here. I guess we can use 15, and then let's put the X right in there, and that's it. Now we could duplicate this, only this one use the front right, and now we should have a very simplistic we might be having a small issue in here. Yeah, it's not getting my input. Alright, I've dealt with that numerous times now. And it's really, usually it's just, you kind of reset these things, and lots of times it kind of just clears up on its own. I find if you're playing with the input outputs, if you adjust things, like as a global, non-global, and things like that, or change the type if that's an option, sometimes it's, as much as it works, it will lose references. That's what I find what happens with the input output as well. But it's being a pain in the ass, so we have an easy way to deal with that, right? We're just going to go into the wheel collider. I'm going to get rid of the next frame, make that the start state, and we're going to take I'm going to take out of the input, and I'm just going to say get FSM float. All right, because we know we're going to have this, we'll call it the main on the car. So we have an FSM called main. We know we have a variable called X, and we can store it as our angle. just like that. And now we have turning. Right, and 15 degrees might not be high enough. You might want to ram that up. I don't know, about 60, yeah, it's pretty crazy. But, you know, 45 might be okay. Yeah, even 40, 35. Yeah, maybe we'll try 35. Okay, so there we have a very simple turning system. And because we're controlling the steering angle on these, that'll control the actual turning of the car. So I'm going to go to all of those, and I'm going to go to the sideways friction, and where it says I think this guy, I think it was him I played with earlier. If I bring him up to 1. Alright, so the other thing is what we're going to want is, I find the easiest, that there is a braking ability you can use, but I find one of the easiest things to do is to set to drag. To me, it works really well. Right, so if here we have a drag of 1, right, and if we say get axis event, maybe we'll use one of those. Event. Where is it? Forward events, UI events. Access event. There we are. And you don't have to use these. I'm just like, if you want to use just get axes and float compare, that works fine too. So if we go up, we're non-idle. And if we go down, we're non-idle. I guess I could just use any direction. We're non-idle. And if we're non-idle, really, I'm gonna copy this whole thing. I'm gonna paste it over here. So we're gonna go from an idle state to a driving state. And in our idle state, actually, I'm going to use just less of a drag. I'm going to use like a 0.4. In the driving state, I want a 0. And this will be, we don't want in any direction, we want a no direction. Then let's go back to idle. Here we go. And here, all we want now is we're going to want to actually have a driving force. I'm going to also do that in another template though. And all we're going to do is I'm going to get axes. Actually, you know what? We could probably use an axes event for that too. Well, I mean, really, either way, whether you want to use an axes event or just get axes and float compare, it really doesn't matter. But if we go up, we want to drive forward, and if we're going backwards, we're going to drive backwards. And if we go forward, what do we want to do? We want to add force. The amount of force we want to add is going to be on a space self, on a Z, let's say drive force. And we're going to do this every frame. Now, with that said, we want to get velocity of the vector. So we'll call this velocity. Well, actually, you know what would be better? Let's just do get speed. This is actually a shortcut. It's the exact same thing, but it gives you a float value. So if you use get velocity, like if you get the velocity, you have a vector 3. Then you can get the length of the vector 3, and you get the speed, essentially. So this is just getting the speed. So this is our current speed. Now, what we want to do is float compare, and if speed is, say, beyond max speed, we need to stop adding force every frame. All right, and if we aren't adding force, essentially we want the same thing, only now we're not going to be adding force, and now we're not going to stop adding force, we're going to add force. Right. And then here, so we're adding our force, we're adding our drive force. Now, we could just do the same thing for backwards, and that's fine. In some cases, you may not want that same amount of force for backwards, so you can use a backwards force. All right, and then we have backwards force as an input and drive force as an input. Now, we obviously need a way that if we aren't doing stuff, right, per se, like that. So I also want to be able to do this, is to go back and forth. Right, so we kind of want to be able to do this. I'm going to go up to there. And we could probably add that same thing down here. And this is kind of more of a, I think more of a little bit of a complex way to do it. Usually you would just kind of add the 1, but whatever. This will work. So here now we have to figure out, you know, what our max speed and all that is, right? Like max speed might be 20. You know, our drive force, you're gonna want to put this really high. Right, like this could be like 22,000. Backwards force could be, you know, negative, you know, 17,000. And just to do a quick little test on this, right? So there's our forward. So we've hit the max speed. And every now and then it pulses back to keep adding that force. And if we go backwards, we can't go as fast. Well, I suppose we can't. We'd have to change that max speed. All right, so let's do that as well. Let's say, okay, max speed. Let's make another one called max speed backwards. And then that would also be max speed backwards. All right, so let's save that as the driving force FSM. Right, Right, so we get rid of that. Boop. And in our driving force, we don't need the non-idle. So we have all this fun stuff, but now we need run FSM. And we want driving force, or depending how I spelt it. Apparently I spelled it horrendously wrong. The forces forward and backwards are fine. I mean, we can adjust those. And that should be good. Right, now this is where you're going to want to possibly, or most likely, start adjusting a lot of these frictions and stuff, like this stiffness here. Like if you're driving on gravel, you might bring this down, right? Like if I go into a slide, it becomes a lot easier to slide around now. Or if I bring this up, oh Lord. Apparently you don't want to go 7. He's more or less like he's saying the wheels are gonna stick, right? Bring that, maybe a 2 is a little better. Yeah. Oh, even a 2 causes flipping. So, but now we have one issue, right? Like as I'm on the ground, he's still wanting to drive. So let's take the stiffness back down to a 1 because that's insanity. And we want another FSM here. And all we want to do in this one is we want a let's go RR input, R left input, front left input, front right. Oop. That's right. Those are all supposed to be game objects. Right, and those are all inputs. Make sure those are going to sit nicely. And all we want to do is we want a ground. We have another one for wheel controller is grounded. You can also get the other one, the grounding properties, and do sideways friction and stuff like that in case you want to do events. We're not going to use any of the events here, but we are going to say front left, and we'll just give it a variable called 1, I suppose. Doesn't got to be anything magical or special. Front right, we'll give that one 2. Close those down. And rear left, give that one 3. Rear right, give that one a 4. And then, most importantly, we're going to make another bool, and we're going to say is grounded. Actually, well, yeah, I mean, we could do that. Yeah, we should do that. Now, I could make this as an output and have things read off the output, but as something a little different, let's do it just slightly different. So let's go any true. Right, so we have 4 variables. We have 1, 2, 3, and 15. No. And 4. So we're going to store it into grounded. So all 4 of these, if any one of those is true, we're grounded. If all 4 are off the ground, we're not grounded. Pretty simple, right? Now, if we want to, we can say bool test is grounded, and this is the part you can actually do up top, and we can say, okay, you know what, we're not grounded, let's you know, send an event. And we're up here, we're going to literally copy this state and paste it up here. Only up here, let's say landed or something. And when we come into these states, for example, all we're going to do is send an event. I said, or if you want, you can output the bool. Either or. But we're going to send an event to our host. So we're going to say landed and falling. I think was the other one we're going to use. I don't want to use the same ones as these things, even though I've got landed here, but this one's spelled with a capital. So we're going to send landed with a capital. And over here, we're going to send falling. I'm going to move this guy up to the top as well. All right, so save. Call car grounding. So we remove that. So we come into a driving thing. All right, so we need to tell it its tires, which apparently I only did 3 of them. So let's make sure to put that one there as well. I mean, I guess in reality they don't need to match up as long as you have all 4. But now we have those 2 events, right? We have falling and we have landed. So all we're going to do is we could actually add it right here if we wanted to, like that, and then just copy this guy. And then do a landed back and forth like that. And if we watch it now, oh, I guess I got to come out of idle. Alright, we gotta fix that thing up because we need the ground check in our idle, which may only make sense. I mean, even if you're idle, you should be able to fall. It's not like you're out of gravity if you aren't moving per se. Banded. Why is that not? Usually you can get away with that. I might have that set up weird. Or my Unity needs to be rebooted, one or the other. Oh, was my... Uh-oh, we have an issue. We have an issue, y'all. that doing? Usually there's no issues with these. Oh. I think I get it. Landed. Because he's sending an event saying landed, which is here, which is telling this thing to run, which is telling this thing to send an event called landed. We don't want to do that. You know what? You know what? I'm going to go back into those things. And we're going to go back. We're going to get rid of that method. Let's turn that stuff back on. Well, let's just use a bool. Should have done that from the beginning. Use it as an output. Right? Get rid of that one. Right, because now we have is grounded. And here, now we can do a bool test. And if false, we are falling. Right, now we should have grounding is true. It started off as false, as everything's still kind of coming in. That's fine. So we just come along over here, paste that in. We're going to go landed. Go. So now, said if I pick it up, we go into a falling state, but I can't add force now, right? That's the whole concept, the whole point of that. There we go. So the other thing you're going to want would be, real quickly, just a small thing. Actually, we don't even need to do a template for this one. It's going to be so small. Well, I'm going to just do it off of mouse button. Get mouse button. So if right mouse button, we're going to run a break. So if break is true, break. All right, I'm going to put those like that. Grab both of those. And I'm going to put them in here as well. Then we need a breaking state. And I'm going to put both those in here, but not that. That would be non-break or stop break or something. You can call it whatever the hell you want. And what the difference between break and stop break is going to be our drag. Right? We might want to take drag up to like 2 during a break. And there's other things you can do. You can also adjust brake values on the wheel colliders. I don't know, the drag for me seems to work pretty good, right? We're going, and if I hold down the right mouse button, it comes to a pretty quick stop, and I'm still holding drive at the whole time. Like I'm not letting go forward, and I hold down brake, right? So it works pretty good in that aspect. You know, 2 might even be a little much, 1.5. So there's that. The only other thing you might want to see a little bit of is normally you would set this up with a few of these different sounds, and you adjust the volume on them and stuff like that. I really don't have a whole lot of engine sounds though, so what I'm gonna do is I'm gonna say, and this is also where you can get like kind of the different gears and stuff like that happening as well. I'm not really gonna worry too much about that. But if this is our RPMs every frame, and this is one of those things that you'd have to play with the values to figure out what really works for you. But I'm going to say, okay, well, let's go, you know, 650 on the RPM, 0 to 650. And then on the low, we want, say, 0.8, and on the high, we want 1.2. And then I can take this audio source, right, audio pitch, set it to pitch. Right now, obviously, you'd want engine starting and various other sounds too. Just kind of shows you the basics of how you'd kind of get that ramping sound effect. Oh, I never put it to loop. Because, like I said, normally you would actually run a few of these all with different engine sounds. So you can have that kind of switch gears and really have that. But you see with the remap, by playing with that. Right. So I wanted to show you that real quick. It's a small little thing, pretty easy to do. That float rate map is on the ecosystem, by the way. You probably won't have that naturally. So there's a car control.